Still on decision rule on net present value. Apart from the decisions we have highlighted above regarding the acceptance or rejection of a particular project using the net present value criteria or method as the case may be, it is important to note that for independent projects, when two or more projects are considered to be independent, then such projects should be accepted provided the net present value is positive. So if all the projects actually turn to be positive using the NPV criterion, then automatically all the projects should be accepted. Apart from that, we may also have one or two projects that are considered to be mutually exclusive, and hence for mutually exclusive projects, and when we talk of mutually exclusive projects, these are projects when only one out of many projects is expected to be accepted and undertaken at a particular period of time. So in this case, the decision rule is that the project that has the highest net present value and which is also positive is actually expected to be accepted. That is how to deal with, independent projects as well as mutually exclusive projects. So our main concern is just to ensure that the net present value from a given project actually turns to be positive. Once it is positive, then such project can be considered and embarked upon because it has been proved to be worthwhile, profitable, and feasible among others. But if we have independent projects, all the projects are expected to be accepted if and only if their NP values are said to be positive. And on the other hand, for mutually exclusive projects, a project that has the highest net present value, which is also positive, is actually expected to be accepted. So these are the ways we can deal with independent projects and other mutually exclusive projects using the net present value criterion. So apart from net present value criterion or method as the case may be, another method that is commonly used in a discounting factor is what we call internal rate of return, and this is an acronym for IRR. We have what we call internal rate of return. The internal rate of return is actually said to be more advanced than the net present value. It majorly tries to cover the shortcomings that are inherent in net present value method. So by internal rate of return, we simply mean the discount rate, which when it is applied to a series of net cash flows, it will reduce the value of NPV to be 0. In other words, the IRR is the discount rate at which the net present value of a project is said to be equal to 0. So that particular rate that can yield NPV to be 0 is what we call the internal rate of return, which is usually put in acronym IRR. Apart from that, the internal rate of return of different projects can easily be compared against one another and against the firm's cost of capital. So it is often calculated by discounting the net cash inflows at different rates until the NPV diminishes or reduces to 0. So the IRR has other names such as discounting cash flow yield, or we can call it marginal efficiency of capital, we can call it trial and error method, or perhaps we can call it actuarial rate of return. These are other names that we can synonymously use with internal rate of return method. However, the internal rate of return cannot be easily calculated directly. It can only be found through linear interpolation, namely, 1. There are two methods we can use in order to obtain the internal rate of return. We can use what we call graphical method, which is known as present value profile method, or better still, we can use what we call interpolation method, or linear interpolation method. These are the two methods which we can employ at a given point in time for the purpose of computing the discount rate at which the net present value is reduced or diminished to 0. So let's look at the procedures that we have to undertake in an attempt to use the internal rate of return to appraise or perhaps to evaluate a given project. One of these procedures is that 1. We use the given discount rate to calculate the net present value for the project. In the question we are going to be given, they are going to specify the discount rate, and the discount rate they have given us, the procedure simply states that we are going to make use of that particular discount rate, the purpose of which is to compute the net present value for the project. Then 2, we actually need 2 net present values. There are 2 values we need to obtain for net present values. One must be positive and the other must be negative. So if the original discount rate actually yields NPV to be positive, then we need to increase the discount rate until we are able to obtain negative NPV and vice versa. So we need to compute our NPV positive on one hand, and we also need to compute NPV negative on the other hand. So once we have gotten the 2 NPVs, one positive, the other negative, then we are moving towards solving the problem of investment appraisal using the net present value as well as internal rate of return method. The procedure 3 is that for the present value profile, which is otherwise known as graphical method, the positive and negative NPVs are expected to be placed on the vertical axis, while the discount rate are scaled on the horizontal axis. That is, if we are using the graphical method, or better still, the method we call present value profile, with a view to obtain the internal rate of return or the discount rate at which the NPV is equals to 0. Then 4, using the graphical method, we have to plot the smaller discount rate against the positive NPV, and on the other hand, we plot the larger discount rate against the negative NPV. Once we have plotted, then there are 2 points we are going to note. These 2 points are expected to be joined together for the purpose of crossing the discount rate axis, and the crossing point will give the internal rate of return or the discount rate at which our net present value will be assumed to be equal to 0. Then finally, we can make use of what we call interpolation method in an attempt to obtain our IRR. And using this, we have interpolation method, and we have the formula is R1 plus, we have NPV plus all over NPV plus minus NPV minus into bracket R2 minus R1. So this is the formula for what we call linear interpolation method. Let me quickly define these terms. We have IRR to represent internal rate of return. Internal rate of return. Then we have our R1, which represents lower discount rate. And lower discount rate, that's R1. We have our R2, which also represents higher discount rate. Then we have NPV plus, which represents positive NPV produced at lower discount rate. And we have NPV minus. This is given as negative NPV, which is produced at higher discount rate. So this is the formula, or what we call linear interpolation method, of obtaining the internal rate of return. So we can use this formula with a view to obtain the internal rate of return. Or alternatively, if we decide not to use the interpolation method, we can use what we call alternative formula. And by this, our IRR is equals to, we have N1R2 minus N2R1 all over N1 minus N2. We can also use this formula here for the purpose of obtaining the discount internal rate of return, where, let me quickly define the terms here, where N1 is equals to positive NPV, whose discount rate is lower, that's R1. Then we have N2, that is negative NPV, whose discount rate is higher, and that's what we call R2. So this is how to use alternative formula for the purpose of computing the internal rate of return, that is the discount rate that yields NPV 0, or that makes NPV to be 0.